Hello everyone, welcome back to my YouTube channel. This is Saana from SVCE Bangalore. Today I'm here to discuss about the network analysis subject. Today I'm discussing about the topic of superposition theorem. Let's we go through this superposition theorem. Here, introduction to superposition theorem. Superposition theorem is a powerful tool used in electrical circuit analysis. It allows us to solve more complex circuits by breaking them down into the simpler parts. The theorem states that the response is any branch of a linear circuit is equal to algebraic sum of responses caused by each independent source acting alone while all other independent sources are turned off. Let's understand the linear circuits. Linear circuits have components that follow linear relationships between voltage, current, and resistance. Components such as resistors, capacitors, and inductors can be considered linear. Non-linear components like diodes and transistors, they do not follow linear relationships and are not suitable for superposition analysis. Let's go through the steps to applying superposition theorem. Here first, we should turn off all the independent sources except one, replacing them with their internal resistance. That too, short circuit for voltage sources and open circuit for the current sources. Next step is analyze the circuit and calculate the response caused by one active source. Repeat the process for each independent source only for a once time. Next, let me consideration for applying superposition theorem. Superposition theorem can only be applied to linear circuits. It assumes that the circuit elements are passive, meaning that they don't generate energy. The linearity assumption implies that the response caused by each independent source is directly proportional to the magnitude of that source. Let's take an example for a circuit. To illustrate the superposition theorem, let's consider a simple circuit with two voltage sources, that is to V1 and V2. And let me consider two resistors, R1 and R2. V1 is connected to series with R1. We will see here in this circuit diagram. Next, V2 is connected in parallel with the R2. We want to find the voltage source across R2 using the superposition theorem. Let's analyze this step 1 with V1 alone. In step 1, we consider V2 as an inactive or zero source because V2 is an independent source. We calculate the voltage across R2 by treating V1 as the only active source in the circuit. We can also use Ohm's law to determine the current flow through R2 and then calculate the voltage drop across it. Next, step 2. In step 2, we consider V1 as an inactive or zero source. We calculate the voltage source R2 by treating V2 as only active source in the circuit. Again, using Ohm's law, we can determine current flowing through the R2 and we can calculate the voltage drop across it. In step 3, we can combine the results from step 1 and step 2, obtain the total voltage across R2. Since the superposition states that total response is sum of the responses caused by each individual sources, we can add the voltages obtaining in step 1 and the step 2. For example, in calculation part, let's consider V1 equals to 5 volt, V2 as a 10 volt, R1 as a 2 ohm, and R2 as a 4 ohm. For example, in this circuit, let's go to the step 1. We should find that voltage across R2 caused by V1 alone is 10 volt. In step 2, we will get R2 caused by the V2 alone is 5 ohm. Finally, in step 3, we will add these three voltages obtaining in step 1 and step 2. The total voltage across R2 considering both V1 and V2 is 10 volt plus 5 volt, it will be the 15 volt. Therefore, the superposition theorem tells us that the voltage across R2 is our example circuit is 15 volt. Let's go through the advantages of using the superposition theorem. Superposition theorem simplifies complex circuit by breaking them down into smaller or nothing but simpler circuits. It allows for easily calculation of individual responses caused by each independent source. By focusing on one source at a time, it helps in understanding the effect of each source on overall circuit behavior. Then we will discuss about the limitations. Here, superposition theorem cannot be used for circuits with dependent source. It will only applicable for the independent source. Next, it can only be used to determine voltages and currents at specific points in the circuit, not the overall power consumption. The technique can become tedious and time consuming for circuits with a large number of sources. The real world applications. The applications of a superposition theorem is it finds applications in various fields such as electrical power systems, telecommunications, and electronic circuit design. It helps in the analysis and design of complex circuits, allowing engineers to optimize performance and turbulent issues. The theorem is also used in signal processing and control systems to understand the behavior of linear systems. Let's at last we will conclude that superposition theorem is valuable tool in electrical circuit analysis. It simplifies complex circuits by breaking them down into smaller parts. By analyzing the response caused by each independent sources separately and adding them up, we can find the total response of the circuit. Thank you for listening. Thank you for giving your valuable time. Thank you.